Hello, dear friends. Welcome to today's class. In today's class, we are going to look at introduction to colligative properties. And in our next class, we will use the information about the colligative properties to determine the molecular mass of an unknown substance. Okay, so let's go. What are these colligative properties? The colligative properties are the physical properties of solution influenced by solute concentration. Okay, so now when we talk about physical properties, we are looking at density, boiling point, freezing point, osmotic pressure, and so on and so forth. These are physical properties. So now these colligative properties are telling us what the effect of solute particles in you know in solution, the effect of solute particles on the physical properties of a solvent. All right, so recall that when a solute is added to a solvent, it will produce solution. So when salt is added to water as solvent, it produces salt solution. So now the salt is a solute, water solvent, then form salt solution, water and solvent and salt. So in the solution here, the effect of this salt on the solvent, would be either to increase, will increase the boiling point and decrease the the freezing point. So this solvent, the physical properties of this solvent will never remain the same in solution. So those changes in the physical properties of a solvent in a solution is what colligative properties are all about. So the colligative properties depend on the number of solute particles, right? By that we mean that when a solute is dissolved in a solvent and it forms two particles. For example, in ionic solutes like sodium chloride, when they dissolve in water, they dissociate and form sodium ion and chloride ion. Now, these products are two particles in the solution. Now, when you compare it with when sugar is dissolved in water, sugar forms just one particle. All right. So now, when we compare this, the effect of sodium chloride will be higher than that of the sugar. So that is what it means that it depends on the number of solute particles. But it does not depend on the nature or type of solute. No, 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 no. So long as it's a solute and it dissolves in the solution, the effect would be the same, right? Okay. But the these colligative particles, colligative properties depend on the type of solvent, right? Yes, it depends on the type of solvent. The effects are different in different solvents. Like the presence of a solute in water would give a different colligative property, a different boiling point property, a different change in the physical property uh, than in when compared with um, presence of when compared with the solvent, or when compared when the solute is dissolved in another solvent, right? So the solvent depends, the colligative properties depend on the type of solvent. Now look at the types of colligative properties. We have the boiling point elevation, the osmotic pressure elevation, freezing point depression, vapor pressure depression. So now This means these are the major types of colligative properties, which indicates that when a solute is dissolved in a solvent, okay, that the boiling point will increase, the osmotic pressure will increase, the freezing point and the vapor pressure will decrease. So this is the knowledge of colligative property. So in our next class, we are going to use this information to see how we can determine the molecular mass of unknown substances. So thank you very much for coming around. If you like this video, please share it, like it, and subscribe to my YouTube channel for more useful videos. Thank you. See you in the next class.